find that graph. So do a control click and then do down, you know. Can't do it?
Give him a little hand.
So you just kind of move the screen around. What happened to our point? What happened to our graph? Okay. So let's see here. Each of these. Let's change this to be. Yeah, what happened to it? Anyone got it? Something happened to it here. We'll let Jennifer work on it. Let's see. Okay. So we've got one here that looks good. What I'm looking at is it would appear, Zach, it looks like you've got something here. It would appear that as we let the input, the width get longer and longer and longer, that the perimeter what are we doing here? Let me go back. I've got a little lost in the problem, I think. This is the perimeter, right? Okay, so yeah, so as we went farther out, the perimeter was actually going more closer and closer to 0. This recorded? There we go. We'll do a recording starting this. Yeah, -15. Go to what 500 on this.
I have that.
Okay, and then scale by 100. You got it? Okay, and then down here we don't need. Okay, and then tab down. We don't need that much, so let's just do -500, and let's go to what 3,500 or 3,000 or something. There you go, and we'll scale by 1,000. Okay. You can start to see this thing tailing up at that point. Okay. So what we have is, this is a good example of what we call in behavior. Our in behavior is that if you look at this from the zoom out that Connor had, or what Garrett was saying he has, you zoom out, it has a different look than if you actually go inside and look nearby. But if we look at 300, it doesn't look like it's by much on this picture, but on the last window we looked at, it looked like it really was a point, you know, it went down and back up. So we are minimizing that. Okay, well, I'm glad that we had that problem. Let's go to another problem. Let's see what else we can get into here. Oh, here's our Norman window one. We won't bother with that since it is for homework. Home gardener estimates that 16 apple trees have an average, oh boy. Hang on a second. Let's go on to another problem, and then we'll come back to problem 20. But I think I'd rather do this one first and give me a chance to look at that other problem before we jump into it. It's not a bad problem at all. Okay, energy drink container has the shape of a right circular cylinder. Can you draw a figure? Can you draw a picture of that? You know this magic pen that automatically corrects if I do something, but you got to draw it right to begin with, so we won't do that. Okay, so a right circular I can draw it better this way. Okay, must have a volume of 16 fluid ounces. Okay? Has to have 16 fluid ounces. Okay, so the volume has to be 16 ounces. Okay. 1 fluid ounce is approximately this many cubic inches. So this is approximately 1.80469 cubic inches. Okay. The cost per square inch of constructing the top and the bottom is twice the cost of constructing the side of it. Find the dimensions that minimize cost. Is this going to be our primary or secondary? Yeah, I think I heard someone say secondary. What is our primary equation going to be? In words. You don't have to have it out in letters and numbers. But Aaron, what do you see the primary one involving? Aaron McHenry. Oh, Aaron. The other Aaron. Yeah, sorry. Well, just put it in words. Don't try to give me a formula. Okay, so we have to find the area of the circular tops and bottom, right? And we have to find then the area of what? Yeah, the surface area of this thing around. Okay, so we're definitely going to look at area. So we have the area of the bases plus the we call it surface area. Let me put that in. And that's the side. That's the side of that. Now, I actually want to minimize cost. Is area really our primary, or do we need to put something else in there? Well, that will come. Yeah, that will come when we find the area. Well, we'll put a height in here of some sort. But we're trying to are we trying to minimize the area? And the cost. So now we got to figure out how are we going to get that. And we don't have the same cost for the top and bottom as we have for the surface area. Let me introduce this. That's an S. S is the cost per square inch of the, let's see, of the, I'll say of the surface area. SA is surface area. So the cost of this, which one costs more? And how much more? So if I find the surface area in square inches and I multiply times S as the cost per square inch, I would have S times this, and then what would I have to do for this? Yeah, whatever I find to be the area of those bases, the sum of the area of those bases, I'd have to then put 2 times that. So I've got 2S times the area of the bases plus S times the surface area. Now I don't have any numbers or any real letters to work with S. I'll use S, but I need to find out some other information here. Okay. Now, we got a couple of secondaries, don't we? Got a couple of things going on. So the primary, actually, this is going to be your primary equation, I think, isn't it? Because we're trying to find costs or minimize costs. So let's see. Yeah, good. I can pull that up here. I'll put that right here. Okay, so that's going to be my primary equation. We need some other help though. I know that the volume is has to be 1.80469 cubic inches, but does anyone happen to know the formula for the volume of a right circular cylinder? How did you come up with that?
Because it was part of the homework.
Okay, if you didn't have this part of the homework, is this one of your homework problems?
Similar to.
Okay. Okay. Well, I'm going to help you out with your homework then. Okay. If you didn't know that from the homework problem, how could you figure it out? Say it again, Laura.
Pi squared.
Some of that sounds familiar to me. Does it sound familiar to you? What part of it? Pi r squared? What's pi r squared? Area of a circle. Okay. So if I have the area of a circle, how do you find, how do you find the volume of a box? You do what? Okay, so if I'm looking at, oops, I guess I need to go back here with this. If I'm looking at length times width, and I have this as length, and this is width, the length times width is the area of the base of this. So pi r squared is the area of the base of this. Same thing, right? Volume is the area of the base times the height. Area of the base times the height. So it makes sense that it would be pi r squared h then. Okay, so we've got that. And so volume is pi r squared h. It's also 1.80469 cubic inches. Did I misread that? Oh, 1 fluid ounce. Oh my goodness, yes. So this has to be 16 ounce. So this actually has to be multiplied times 16. Okay. So this would be, well, wait a minute. Hang on a second. If I'm finding pi r squared h, if this is r down here, and this is h, I found this to be this formula, and so yes, I agree. I'd have to take 16 times that. Thank you. Cubic inches. Okay? Now I've got, how many variables do I have so far? I've got 2. What do we have to do here? Find a way to put it down to 1 variable. Okay. Now this is the volume. Okay. We need to find the area of the bases. So what's the area of one base? Pi r squared. Okay. Area of 2 bases would be twice that. Okay. What is the area of the, or what is surface area? Area of the sides of that. Well, just to right here. What's the surface area?